Okay, so TrafficMaster speed data is centrally purchased by the Department for Transport and uses Teletrack Navman's GPS data set. And this is based on the output, we think somewhere around 130 to 150,000 vehicles who are effectively polling data every 1 to 10 seconds as they're traveling about the road network. The data is attached to Ordnance Survey's ITN and more recently Highways data. It's an extremely heavy data set with millions of rows of data. In fact, I believe there's around about 20 billion counts per annum of data. The challenges the data presents, it's obviously because it's a complicated and detailed data set that there's detailed knowledge of SQL required to load the data and run queries. They can take quite a long time to run, and obviously the data doesn't easily distinguish between different directions of travel, the A and B links, which Dan will cover when he does his demonstration. And because of that, it sits in a great many authorities being underutilized because of the fact that it's difficult to use. And just to show why TrafficMaster speed data is important, if we just use ordinary standard speed data from the DFT and looked at a 15-minute drive time within Waterloo Station, as you can see, there's great swathes of London that suggest that you can drive to Waterloo Station within 15 minutes. Any of you that know London at all will know that that's physically impossible. But just by plugging in the TrafficMaster speed data to Highways Analyst, it now produces realistic drive times. And obviously the numbers of people that can access within that 15-minute drive time based on morning speeds is much, much lower. So Highways Analyst itself is a web-based tool, it sits in the cloud. So it's a software as a service. It exports into various formats and the data is held at link level. So it can be queried against days, dates, times, roads and vehicles. The data is sort of aggregated into 6 time bands: AM peak, PM peak, off peak, evening, night time and weekend. And the DFT who hold the data can provide up to 8 years of data to local authorities for road traffic analysis. And the DFT have been supporting TM speed data for a number of years as their go-to data set, which they use for their journey time statistics and analysis. I won't go over these in any huge detail as I'll be sort of stealing some of Dan's thunder, but he'll show how you can use the data in different ways in terms of trying to look at where congestion, slow speeds and pinch points are on your network, modeling sort of changes to the road infrastructure, looking at speeding. Anecdotally, I've even heard of 1 or 2 who are using the data to supplement some of the work they're doing around sort of air quality to show where certain links speeds are extremely low, where traffic is obviously at its heaviest and therefore potentially having an impact on air quality. Kingston upon Thames kindly did a case study with us. I won't go into it in any detail now, but I am more than happy to send the case study to you. But they've been using Highways Analyst now for around 3 years. Have found some really good use cases for the data and the fact that it can do that analysis much quicker. For White has just basically put a nice little sort of quote on there that they found it extremely valuable across the council to deliver robust and accurate analysis for a wide range of colleagues working on a number of different projects. Travel as well have used our Highways Analyst and the TrafficMaster speed data, and the one thing that for them was the amount of time that it saved in doing that important analysis. Over 112 hours saved from using Highways Analyst against the sort of manual processes that they were using beforehand. And there's a nice little quote there from Anthony Piccaro, the Information Intelligence Officer at Mersey Travel. So that was it. I just want to run through a couple of slides for you. What I'm going to do now enter, and if the technology works, hopefully Dan, do you now have control?
I do indeed, and I hope to have just shared my screen. You can now see Highways Analyst in front of you. Is that right? He says in a hopeful manner.
Yeah.
Yes.
Good. Brilliant.
Yes.
Okay, excellent. So what I've done here is I've gone to Highways Analyst, and the first thing you get when you go to the website when you reload it, it zooms in on the area in which you have data for. So I looked at our existing clients and who was kind of local to you. So I chose the Borough of Croydon, who are one of our Highways Analyst clients. So I'm just going to be a bit cheeky and jump into their data to give you a demo. So effectively, as Lester said, it's a web tool, so you can access it from anywhere, and it basically allows you to zoom in areas and decide where you want the study area to be. So the very first thing you need to do is work out actually what am I interested in looking at. So this very first query, I'm just going to use the selections on the left hand side, draw a box that covers kind of central Croydon. What I'm then going to do is use the wizard tool. Here I'm going to select I'm using a map. I can upload custom boundaries. So a custom boundary would be something that I've uploaded as a GIS file, or it could be a CSV file of a series of links, or it could be something that I've saved on the map. And a boundary name would be an existing boundary. So it could be the whole borough of Croydon in this example, or it could be particular wards within that. But I'm going to choose the map option. I'm going to go next. I can then choose a date range. So we're just releasing the 2019 data at the moment, so something goes up to the end of 2018. So I'm going to just choose the month of December 2018 just to make it run nice and quickly. So 1st of December to the 31st of December. I'm going to choose a time range. These can be selected in 15-minute periods. So 7 AM to 9 AM, I can do 7 to 7:15, 7:30. So I'm basically going to do a 2-hour study just here. I can then, because the TrafficMaster data in its source has a vehicle type, we can tell what type of vehicles you want to include as part of this. So I've got cars, I've got LGVs, I've got the 2 different types of HGVs, and I've got other vehicle modes there. The reality is most of the data is in the cars and the LGV category, about 92% of the data, and the rest of the data is included in the other types just here. And then choose which days I'm interested in. So I'm going to do Monday to Friday for this first example. Now, because in the data there's always anomalies where you might have a vehicle that's driving too fast or too slow, we have the option here where we can remove a percentile. So what I mean by that is we can top and tail the results. So I could say I want to exclude the top 5% or the bottom 5% of my results. So I could put 5% here, and it removes the 5% of the fastest values and 5% of the slowest values to remove any kind of extremes. I'm going to leave it blank for this example. I'm then going to choose I want to include or exclude school holidays. So in the data we get, we basically provide a CSV file to each authority where they can enter their unique school holiday dates, and we load that data in to Highways Analyst. And why that's interesting is during a school holiday, generally there's much less congestion, especially in the peak times, because people aren't dropping their children off at schools. I know personally, I can get to work 5–10 minutes quicker during the peak. But you might find different traffic compared to different parts of the day. So maybe around a leisure centre or something like, you might start getting traffic in inter-peak time. So we can choose to include or exclude that data automatically. By default, we show what is the speed against that free flow. So it can kind of give a general indication as how traffic flow is going against congestion. So anything we can see in black is 30% or less. Anything that is red between 30 and 40, and so on and so forth. So we can also change it from being a percentile. We can change it to be a speed. So I've got now in 15, 30, 45. Now the speed unit is depending on what you have in the settings. So in my settings here, I have it set to be in miles per hour, but if you wanted to, you could set it to be kilometers per hour as well. So now any link that's applying in black has got an average speed of less than 15 miles per hour, and then red's 15 to 30. We can zoom in on some links. Then when I zoom in, we start showing some additional information. So first of all, you'll notice that these links here, we've got some arrows that are appearing. So from the highways data or the ITN data we're bringing across, is it a one-way road, and what direction is it a one-way road? And if I zoom in even more, we'll then start seeing that one link here gets offset into two links. So we try to copy a Google Maps SQ here showing traffic in bi-directions. So this is what Lester alluded to earlier on with an A side and a B side. So if I was to click on one link just here, it's going to populate the B side, so it's on one side of the road with an average speed of 18.99 miles per hour. And if I click on the other side, it shows me the speed in the other direction is 19.76. So in this example, they're very, very similar. Also, as we mouse over the link, we have the link ID. So this is a unique link identifier provided by Ordnance Survey. We have the average speed for that link, the minimum speed that was recorded for that link, the maximum speed, the free flow speed, and also the count. So interestingly here, the free flow speed is really low for this link, so I'm not sure why that would be. This link it is, and we've got 173 counts of data. So what you can do is you can start building routes up by multiply clicking links as they go through, and you'll notice then that the length will increase, the time it takes to traverse through the links will increase as each one is selected, and the average will change based on the average for all the links. And if I do it in the opposite direction, we'll see the same thing happens, but it's now populated in the A side, which is going the other direction. So we can actually see generally there's not a lot of difference. There's 2 seconds in journey time difference between traveling through these links. Now this could be quite hard work if you have quite a long route you want to analyze. So we also have a mode called waypoint mode. So if I just unselect all my links and say I was really interested in looking at access through the Croydon flyover, I could choose waypoint mode here. I could choose a start point, it might be this junction just here, and choose an endpoint, which is maybe up to the roundabout. And I can run the waypoint. And effectively what I'll do is I'll work out the journey between one and the other. I could then, using this, get a summary of the average speed, the route time it takes to traverse through here, and the route length. And I could then export this out as a tabular report or as a shapefile. And this will then give me for each of the links the information for that, which is just open on my second screen. So just drag that across. Instead, hopefully you can see that here. So here we've got each of our links. We've got the average speed for each link here. We've got the road types. This is a lookup for 3001 is effectively an A road. We've got what the free flow speed is. We've got the length of the link here. We've got the maximum speed that's recorded, the minimum speed that's recorded, the name of the link, the amount of counts that were recorded between 7 and 9 for the month of December, an internal ID, which is something that we use at Basemap to look up a link. And we have that OS link ID we spoke about a moment ago, and the time it takes to traverse through each link individually. So you can summarize these and see it's 104 seconds, as matches the interface result as well. In this example, everything's a one-way road, so everything's populated in the A side. But if we're looking at other data, you may have some things on the A or some things on the B, depending on the route. What we could also do as well, if I go back to Highways Analyst, we can divert this route. So I can click on the route and drag it somewhere else. And again, like Google Maps, it will read it. So instead of going over the flyover now, we're effectively coming off before the flyover starts. We're then going round the roundabout, getting back on the flyover to get to the roundabout. We see the link length has increased slightly, but we see the route time has increased by another 15 seconds or so to do that extra diversion. And then if you wanted to, you could save this selection out to be used over and over again. I'm not going to do this. This is a live system, so I don't want to mess up Croydon's data by putting a weird route in there for them. But you can save that and requery it in the future as a custom link. What we can also do as well is if I just clear the selection down just here. If we were interested in a particular area at the moment, so I was interested in this link, which looks quite congested now, I can then use a chart tool. And what the chart tool does effectively is it gives me information on that link across a 24-hour period, and it can work on multiple selections of links. But to make it a bit simpler, we'll look at this average time it takes to the average speed. So I've got selected it takes to traverse through that link over 24 hours. So you can see the average speed column is on the left-hand side. So here we can see at midnight the average speed is 30. It goes up to 35 at 5 in the morning. You can see it slowing down at 7, at 15, and at 8 it's at 14. We can see that in the interpeak it speeds up slightly, and again gets to its slowest speed at 5 o'clock in the evening. We can look at the travel time as well. Again, so that's the travel time on the right-hand side. I can effectively see it's a mirror image of that, so we can see the travel time takes longer as the speed decreases. We've then got the same for maximum and minimum. So if we look at the average, we look at the maximum speed and see how that changes, and the maximum time and the minimum as well. And here we can top and tail the results. If I choose 10% and refresh, and then remove the quickest and slowest 10% of the counts of data in each direction. This can also be exported. So if you want to produce your own custom charts in Excel, you can do that by the export option. And this actually breaks down the data into even more granularity. So this now becomes across in 15-minute periods. There's a couple of 15-minute periods in our accounts. We don't have any data, but generally every 15 minutes we're going to get our average speed, our minimum speed, maximum speed, average journey time, minimum journey time, and maximum journey time. That comes all through there, where you can do any sort of queries you'd like. So what we can also do as well is if I clear my selection and reset the map, I can do another query over here. And using the wizard, I could do a comparison. This time, I'll still look at the month of December. This time, I'll look at 7 to 9 in the morning in one calculation. I'm going to do a comparison, the month of December 2018, but this time I'm looking at the evenings. So I'm going to do 1700 to 1900. Monday to Friday includes school holidays. Let's save data and go finish. And let's hopefully just do 2 quick calculations. So do one Monday to Friday in the morning peak, and then one Monday to Friday in the afternoon peak. So we get the same view of data just here as we saw a second ago. In our report 1 that's been selected. But we can also do it select report 2. This updates the map now showing the evening speeds. And the other comparison. So the comparison will show anything that is in black or red, where it's slower in the first report to the second report, and anything that is orange or green is faster in the first report to the second report. So we get a different view of results just here. And again, with this, we can do the same kind of export. So if I select some links just here, I would choose the tabular report and choose my selected links and generate the report. And what we'll just do this time is it adds a bit more information. So we'll get double the amount of results in here. So we'll get results for report 1, which is our 7 to 9 in the morning, and report 2, which is 5 to 7 in the afternoon. And then we get a column here that subtracts 1 to the other one. So here we see the average in the morning, it was 14.7 for this link. The average is 13.7 between 7 and 9, so the difference is 1. And we see we've got real extreme examples. We've got 15 and 11 here, so we can see that this road, the A3T2 in this particular link, we can see a big kind of swing in the results that are coming across. And this is repeated across. It's the same reports as early on, just with twice as much data, so the counts are duplicated as well, and the time across each time period as well. We can also export this data out all the links, so not just a selection across the whole network could be done, as also as a selected area. Also, if you do use any other type of GIS systems, we can export data as a shapefile. We have 2 options here. So one is a routable network, so every link will have the speeds, all the links will join together. So if you put it into a drive time beta software, such as our track software, and you can produce drive time isochrones like Lester showed during his presentation. Or you can do a link per direction. So a link per direction will effectively not match up. So if I zoom in to this part here, link per direction is like a Google Maps view, where you have a link to each side of the road. So you can start each one of these differently if you want to, but because they don't join up, you can't route through it effectively. So you've got 2 different options there that comes out as a shapefile. Also, because the shapefile can't have blank values, you can put in an arbitrary number here, such as -1, so you can delete them in post-processing if you would like. What we can also do as well is we can print a map as it looks. I'll select my map. And this effectively then produces a PDF out the system with your range of scale at the top right, relevant copyright notices at the bottom, and gives you a map view effectively of what you've got on screen at the time being. So if you want to put it into reports or anything like that showing speed, you could do that as well. And what we also allow to happen as well is in the settings, we allow you to do raw data downloads. So if you wanted to interrogate the millions of raw links, you could do that. We've also got a help guide, which links to a PDF that talks through how the application works as well. And we've got various settings. If you're doing custom scales, you can do this here. So here's my speed at 5, 10, 20. We can make one of these default or my percentage. We can also choose miles per hour or kilometers per hour, and here we can upload our custom boundaries if we wanted to. Also within the system, every time we see an eye like this, it's clickable, and it gives a bit of information of how that feature works and how it can be utilised as well within the system. The only other final thing to mention as well is on selection tools as well. We do have other selection tools that can be done, so you can, for example, do a linear selection if you want to look at both sides like this. You can use that to select them. That was quite a big buffer on there. I can reduce that in the settings as well. Or we've got a polygon selection where you just click on the map, the area of interest, and that'll select everything within that as well. And yeah, and effectively that is our Highways Analyst tool. So it's all basically about processing all the large amounts of TrafficMaster data in as quick and efficient way as possible. So thank you much for that. So a new feature we added recently was to add a percentile into the export. So not only can you get the average, you can get things like the 85th percentile. I'm not sure if this is something that is important for you at all, but we can get the 80th percentile of speed as an export. So once you've done the selection, you can choose on your tabular report, enable percentile. Then once that's done, you can choose whatever percentile you're interested in. So I've chosen 85th percentile just here. And then it gives you effectively a different value, different results. So let me just load this up. So we've got our average speed and everything else like that across our 2 time periods. And then here we've got an 80th percentile. I'm not sure if you can see that on your screens at the moment. So this is if you were to line up every count of data from the smallest to the largest, what sits at number 85% of all of them results. And this is quite an interesting thing that's used not to work out when people are speeding and things like that. And that percentile is completely customizable to put any value in there to add further information to any reports that are done out of Highways.